All right, so here we're supposed to, this graph depicts a sine function in the form, what we've been looking at, a sine bx plus c plus d. And we're supposed to estimate the amplitude, the period, the average value, and the horizontal shift for each graph, because we're going to do a couple of these, I think, at least two. Okay, and then we're supposed to write an equation of the function. All right, so what do we have here? Well, let's look at the max. So the max, I'm going to guess that's 9. And our min, I'm going to guess that's -3. So what we need to do is we need to take the 9 minus a -3, and what does that give us? Oh, and then we're going to have to divide that by 2. So 9 plus 3 is 12 divided by 2. That's equal to 6. And so what we're finding when we do that is going to be our amplitude. And so our amplitude is 6. That's equal to our A. Now, how do we find kind of what our D is? Because our D is going to be our shift. And so here we're going to take 9 plus a -3 over 2. And so 9 minus 3 is 6 over 2. So that's 3. So that's our D. So that's our average value. So up here, that's our average value. And that says then, if we go from here to here, that's our amplitude. And that should be 6. So 9 minus 3 is 6. And if we go from here, 3 minus 3 is 6 as well. And so A is equal to 6 here as well. All right. So now what we need to do is we need to figure out the period. Well, trying to do that, I'm going to guess this point and this point because, I'm thinking that looks like it's roughly there. That looks like it's roughly there. And, I'm going to go out on a limb and say that's 1, that's 3. And so 3 minus 1, that's 2. That's basically my period. But remember, I want b because I'm going to have to write an equation for the function, and so I'm going to need b. And so our period is 2 pi over b. And so if I set that equal, maybe we should do this, set that equal to 2, then I can take and put the b here and the 2 here. And so b is equal to then just a pi. Okay. So that's how I would get that. And then the last thing I need to do is I need to find C. Now this is a key thing. We have to kind of go back here and we'll get the equation we need. C is going to be B times the horizontal shift. So that one, if we go over here, oops, too far. We have to think about what it is. Well, B is pi, and a horizontal shift. Well, if we call this the average value, that's going up. So we need to think about what is that point there. Well, here, and I think I moved that. That should be a little further. I think that should be over here to make it equal. And yeah, it might even be further over than that. But anyway, let's. That looks about there. So this is about half, about here. So that's less than half. What's less than half? I don't know. Maybe it's 0.4. Okay. Now the key thing to think about, we shifted what way? We shifted to the right. And so really this number originally was going to be a negative. And if I call it 0.4, 0.35, 0.45, I don't know. Let's call it 0.4. I don't know. We had to go in the right direction to move to right. So that means that had to be a negative because this is positive. We already know that B is positive. And so that has to be then a negative 0.4. Now, that could be a negative 0.4 pi, or we could say, okay, well, what is 0.4 times pi? Well, that's going to be 1. So it's going to be a negative 1.257 is going to be then my estimate for what that's equal to. Okay. And so now I have all the pieces. I've got A, D, B, and C. And so I can say, okay, well, let's say f of x equals A, which we said was 6, sine B, we said was pi times x, and then minus 1.257, which was the C, and then D is going to be plus 3. Okay, and so that then is my whole function worked out to give us the actual equation for that graph. Now, again, key parts are, I don't know that value if it's for sure 0.4 or negative 0.4 if you think about it being shifted to the right. Do I know that that's exactly 1 and exactly 3? Not really, but I'm guessing that's as close as it gets. So based on the graph and my estimates, that's what I'm going to say my actual graph is. And again, if it is, it is. If it isn't, well, we were pretty close, I would say, and that's as good as we can actually do. So that we'll go with that one. Okay. Let's see. How about the next one? All right. So looking at that, it looks like we have a max of 5 is right up there, and a min is 3. And so 5 minus 3 is going to be 2, divided by 2 is 1, so it's going to be a value of going to be a 1 for our amplitude. And so that means that's going to be in here, something like that. So amplitude A equals 1, A equals 1. Well, that gives us then, if we go from there, D is equal to 4, right? So what else do we need? Well, now we have to think about how far our period is. So we're going from here to here. So eyeballing at 20 to 8. So we have 20 minus 8, that's equal to 12. That's the period. And so 2 pi over b is equal to 12. So if I take and multiply by b, divide by 12, b is equal to pi over 6. If I take 2 divided by 12, is 1 over 6. And then, if we need to calculate the actual value, we can say, okay, pi divided by 6, and that's going to be 0.524. Okay, so that's going to be my guesstimate for B. Again, that's assuming I'm correct, and going down here, and that's about 8, and going down here, and that's about 20. It's hard to say because it's not exactly 8 and it's not exactly 20. It looks like it's offset, but it looks like it's offset by about the same amount, and so I'm going to assume that's about where it's at. Okay. All right. What else do we need? So we have A, D, B. So now we need C. And so C is offset. So where are we at for offset? Well, if we go over here, that's going to be where it's going to be our D point that we need. And if we go down here, it might be somewhere about there. That would be 6. That's going to be then in 5. It's going to be over 5, and maybe it's actually more with a piece of paper. Maybe there, maybe 5.5. I don't know. Get a good number. It's easier than 5.2, I guess. So remember, that's going to be an offset of 5.5, but we moved right. And so it's a negative 5.5. And so we need to take our period, which we found was the 0.524, times our offset, which is a negative 5.5. And again, this is approximate, so 5.524 times 5.5, and that's going to give us 2.882. Again, if we kept this as pi over 6 times that, and we would get a different number, because then it's not going to be the rounding here plus the rounding here, getting the rounding here. It's going to be a lot more accurate than that. And so A, B, C, we've got all 4 of those. So f of x equals a, which is 1, so we don't need to put anything. Sine b, which we said was 0.524 times x, and then, oops, there's a negative there, and then minus 2.882, and then d we said was 4, so plus 4. Okay, so that, in theory, should be what our answer is. And again, you know, we'll be off here by rounding, we'll be off here by rounding, and so if we graphed it, would we get exactly what this looks like? It'll be close, but it won't be perfect. Okay. All right, what about this one? Okay, well, this one, they give us the model, so it's a new thing. And so it says a model for the mean air temperature at Fairbanks, Alaska is given, where X is the number of days since the last day of the previous year. Okay. And write the amplitude and average value of the model. Okay, so let's do that first. A. So amplitude, well, I guess A. We have too many A's here now. Amplitude, that's going to be equal to this A here, which is 37. And it's going to be in degrees Fahrenheit. So let's go ahead and write what it means. Okay. Average value. Well, the average value is there, D, so that's 25 degrees Fahrenheit. Okay. Now B, calculate the highest and lowest output values for this model. Okay, so what's the highest it can be? Well, if the highest value is going to be in here, it's going to be basically our 37. That's going to be our highest. Oh wait, and 37 is going to be, we're going to have the output values. So we're going to be going and having to do our D plus our A, because we have our average plus our amplitude. So here's our average, which we said was 25. Our amplitude here was 37. So that's going to be our max. So 37 plus 25, and that's going to be 62 degrees Fahrenheit. Now what's our min? Well, now if we go the other direction, we go down this way, and so it's going to be a 37. Still, it's going to be, that's how high that is. So it's going to be 25 minus 37. Oops. That's a minus 12 degrees Fahrenheit. Okay, so I put those backwards. It should have been D was 25 plus A, but, and maybe we'll do that just so we don't get confused here. Okay, so D plus A, D minus A. So we had to go D plus A and D minus A. And so that's kind of where we are for our output values. And so write a sentence interpreting these in context. Well, we can say, what was this? The mean air temperature. So we can say the mean air temperature of Fairbanks is between 62 degrees Fahrenheit and negative 12 degrees Fahrenheit, or something like that. Okay, so that's going to be our high, and that's going to be our low. All right. C, calculate the period of this model. Well, period, okay, remember that's going to be equal to 2 pi over our B, and B in this case, well, here they sort of split it funny. We have to think and multiply this, because C would actually be 101, negative 101 times that, but B is just going to be the 0.0172. Oops, yeah, 172. And so if we plug that into our calculator, 2 pi divided by 0.0172, and that's 365.30, sorry. Okay, and that's going to be days. Okay, so that's the period. So then what it's asking is, therefore, is this model useful beyond 1 year? Well, a year is 365 days. We're 0.3 days over it for this model. So I would say yes, it is good for 0.3 days beyond 1 year. Okay, so that's what I would say. Now, 0.3 days, that's not a lot, but it is good beyond that year. So that's what I would say with that one. All right, so I'll stop there and I'll come back.